So guys, I want to look at this counting sort problem that we have in front of us. If you look at this counting sort problem from a theoretical standpoint, you may find this a little complicated. So the best way obviously is to look through an example and see how we can do it. So I have this problem in front of me. I have done some prep work for this and I'll explain you why I did that. But let's start to look at this problem first of all. So we have um, an 11 element array which has numbers from 0 to 6. So the range over here of the numbers is from 0 and the highest number is 6. So it's from 0 to 6. As a first step, you want to create a frequency count of this particular numbers. So you basically want to understand if you have an array of elements, you want to see how frequently do they appear in the subset. So in this case, we have a 0 which appears 2 times. You can see it over here and here. You can see 1 which appears twice as well over here and over here, and so on. So we wrote up this as a step 1. We would write up this frequency count table. Now we want to, if we want to solve this problem, we want to see our target as well. So we know that when we will sort this array out, it would probably look something like this: 0, 0, 1, 1, then 2, 2, 3, 3. There's obviously no 4, then there will be a 5, and then there will be 2 6s. So this is our 11-digit element array, which is at the sorted place. Now, obviously, because we wanted to get in a sorted way, so we want to create the second step, a count array. So what I mean by a count array is basically, what do you think would be the position of a given element at its max place? So if we start with 0, we have 2 zeros. So if you look at this position, this is position number 1, this is position number 2. So your 0 can have a maximum position of 2, right? And then if you look at number 1, it can have a position, because they are 2, so it can occupy a position of 4. So the easier way to get it done is, you just add 2 plus 2 and you get 4 here. For 2, because 4 numbers have already appeared and you want to see the next 2 numbers, which are 2, coming over here, it would be 6. So the maximum position of 2 could be 6. The maximum position of 3 again could be 8. Now it will appear at 7, it will appear at 8, but the maximum position is what we are looking at. We also know that 4 does not appear in this subset, but that's fine. We can just write 8 over here again. When we go to 5, it will be at the maximum position would be 9 always. 6, the maximum position would be 11. So we make up this step 2, which is a count array. So just to reiterate, we created up a frequency count table, and then we created up a count array for this as a step 2. Now, if you have done this kind of work already, then the next part is just to put the numbers at the right place. And so we will use this array and this array, or these are 2 subset of the frequency count and the count array, to see how we can achieve the solution at the end. So let's start with this. So we start with the last number of the array. The last number over here is number 2. Now, if you look at number 2, you see that number 2 would have the maximum position of that would be 6. So we want to write 2 at over here, right? Now, if you have 2 at position 6, then let's write down I think the count array needs to be updated then. So in this case, our count array would be 2, it would be 1 would be 4, and instead of 2 with 6, we will have 5 as our counted array. Now, why did I make it as 5? Because I already put 1, 2 at its right place, the next 2 that is going to come at this position, which we are going to visit later, has to be at the right place, which is the right place is number 5, which is this place. So we have to reduce the count array by 1, and we'll keep doing this with every step. So our updated count array is 2, 4, 5, and then we can pretty much copy the rest of the numbers as it 8, 8, 9, and 11. All right, so we passed that test. Let's move on to number 3. So number 3, if you look out over here, in the count array, the position of number 3 is 8. So as a step 2, you want to write 2 as it is, and you want to write 3 right here at the position of 8. Now if you write 8 over here, then obviously 8 is going to be reduced by 1, which will become it 7. So it will be 2, 4, 5, 7, 8, 9, and 11. Again, we move down to number 1. Number 1, we see the number position, the only position for that is 4. So we can actually look over here. We should start looking at this one now. So we see 1, the position for 1 is 4. So we can write 1 here. We can write 2 as it is. We can write 3 as it is. Now 4 would reduce to 3, because how many 4s did we had? How many 1s did we had? We had 2. So we'll reduce the position of 4 to 3. 2, 3, 5, 7, 8, 9, 11. All right. Next, we move down to number 6. Number 6, we know the number position of 6 is 11. That's the maximum position. And how many 6s do we have? We have 2. So obviously, when we solve this position, it will be 10, and 6 would appear at 11. All right, we move to number 5. Now we know that 5 should appear at 9. So, before we do that, let's just copy the numbers as it is. 1, 1. So yeah, the next number is 5, and we know the position of 5 is number 9. So because 5 is only repeated once, so I just have to say 5 that appears at number 9. So I can just write 5 here, and I can update this to a number 8. We can obviously copy as it is the other numbers. So we'll copy them as 8, 7, 5, 3, 2. And just to keep the sanity of the other items, we'll just keep them same over here. All right, let's copy the other numbers. 1, 2, 3, 5, 6. So we've already done 5 numbers. Let's move on to the next one, number 3. So number 3, as we know, number 3's position is now number 7, which means this is the position where it should be next. So I can write number 3 right here. Now obviously, because this is the last one of them, this would turn down to 6. Then we can keep all the other numbers as it is. 2, 3, 5, 6, 8, 8, 10. Let's copy the numbers as it is. 2 comes from 2, 1 comes from 1. All right, let's move to number 1. Now we know the number 1 last position is 3. So when we see 3, it's open here. So we put number 1 here. Obviously this 3 would change to 2. Let's copy this 2, 5, 6, 8, 8, 10. Let's copy the other numbers. 1, 2, 3, 3, 5, 6. Next number is number 0. Now we know it's number 0. The maximum position for that is 2. So it should come down somewhere here, which is here. So it would be 0. And then this 2 would change to 1 because we have 2 of them. So 1, 2, 5, 6, 8, 8, 10. All right, so next move down to number 2. Number 2, we know the number of last position of 2 was 5. So we know that 2 is here, so we just can copy it over here as 2 over here. And then we reduce this 5 to a 4. All right, so let's do the other work, which we the leftover work which we didn't complete it last time. 5, 3, 3, 2, 1, 1. This is 2 now. 0, 1, 1, 2, 2, 3, 3, 5, 6. So now this is 4, this is 2, this is 1, 6, 8, 8, 10. All right. All right, we have almost completed 9. We are on the 10th item, which is 0. So again, 0, last position is 1, which is the first position now. So we put 0 right here. And we put the next, copy the other ones as it is. And then we reduce this 1 to 0. 2, 4, 6, 8, 8, 10. Lastly, we have 6, which will obviously come over here. This will reduce to 9, 8, 8, 6, 4, 2, 0. So this would be 6. This would be 9, which is the position that it's trying to say. Copy it over there. So we have 5, 3, 3, 2, 2, 1, 1, 0, 0. Now, if you look at this solution that we've achieved, it is pretty much the same solution that we wanted to achieve over there. All right. So that's how you can do the algorithm for the counting sort. Now notice that if you are preparing for the exam, you might want to create this 11 by 11 array upfront, which is basically the number of elements that you have in the array. And you want to find the unique numbers and create another array of 6 by 11 elements over here as well. And then it should be pretty simple. This would also, be easier to do with a ruler. So that's just a tip that how I felt would be very helpful. So yeah, that's the way how you do it. Thank you. Bye.